What are limits? What does it mean to find the limit of a function? Let's take a look at this idea. Let's look at the function 1 over x. As x gets closer to 0, the values of f of x grow larger in magnitude, positively on the right and negatively on the left. Let's take a look at the dashed red lines. These represent asymptotes, which is what the graph approaches but never touches. Here the function has no defined value at x is equal to 0, yet we can still discuss what happens as x approaches 0. This is the heart of the behavior of limits. The notation, the limit of f of x as x approaches c is equal to L, means that as x gets closer and closer to some value c, the output of the function approaches the value L. Let's break this process into 3 steps. Start with x approaching c. Then, we observe how the function moves closer to L. The last step is to conclude that L is the limit as long as both sides agree. This definition gives us a structured way to describe the behavior of a function, even at points where it may not be well defined. Let's consider the function sine of x. This function oscillates periodically, and let's examine the limit as x approaches pi. At x is equal to pi, the function value is 0. But what happens as x gets closer to pi from both sides? As shown, the graph approaches the same value 0, whether we're coming from the left or right side. This illustrates that the limit of the function as x approaches pi is 0. An important distinction is that the value of a function at a point may not always match the limit at that point. Let's consider the function f of x is equal to x squared, with a hole at x is equal to 2. This graph shows that the limit as x approaches 2 is 4, because the function approaches 4 from both sides. However, the actual value of the function at 2 is 2, represented by this blue dot. This gap highlights that limits focus on approaching behavior rather than the value of the function itself. Let's explore the left-hand and right-hand limits. This piecewise function, as x approaches 3 from the left, f of x follows the blue line, and the left-hand limit is 3 accordingly. From the right, it follows the orange line, and the right-hand limit is 4. Since these limits do not match, we say that the limit of this function at x is equal to 3 doesn't exist. This is a crucial point. Limits must agree for both sides to exist. What's the limit of f of x is equal to x squared as x approaches 1? Take a second to figure this out. As shown, as x approaches 1 from either side, the output of the function clearly approaches 1. And in this case, the limit is equal to the function value. To summarize, limits describe how a function behaves as the input approaches a value. The limit is not necessarily the function value at that point. For a limit to exist, the function must approach the same value from both sides. Thanks for watching this video on limits. I've linked here a previous one on the basics of functions, and please like and sub. More videos to come soon.